In this video we'll look at calculating the volume of a prism using the formula V equals AH. Now, first of all we need to understand what a prism actually is. So the definition of a prism is a three-dimensional object with a constant cross-section. In other words, there is a constant shape which runs all the way through that 3D object. So for instance, in this triangular prism up here, this triangular shape here runs all the way through from front to back. In other words, if I was to look at the back, that same triangle would be there, and if I was to cut it anywhere on any of these slices here, then I would end up with that same triangular shape running all the way through. This prism here, although this has not got really a name, if I was to slice this at any point across this way, I would look down on it and I would see this exact same shape. Now, before we go on, something about the formula here. The formula can sometimes appear in different ways. We have volume in this case equals A times H, which I'm going to take to mean area times height. But you'll sometimes see this formula written as volume equals area times length. Basically what you've got, regardless of whether you use an H or an L in this space, the A is the area of the constant cross-section. So on a triangular prism, where A is the area of the triangle. On this prism here, this is the constant cross-section. So it would be the area of this kind of shape here. Now, just depends on which way the kind of shape's written. So sometimes you would expect this to be what we call the height of the shape. And on this question, you wouldn't normally associate that with height. You'd normally say probably the length there, and you would think about the height of the shape being from here to here. But if we just use the one formula and we take H or L to mean, for example, in a triangular prism, the distance between the triangle at the front and the triangle at the back, that can either be written as H or L. So basically that's going to be that number there. And again, this shape here and the shape that is the same on the bottom, H is the distance between that shape and the exact same shape at the other side of the prism. So as is written here, A is the area of the constant cross-section, so area of the triangle in that case, and H is the distance between the congruent faces, so the distance between the triangle at the front and the triangle at the back. Now, we'll look at two examples where we have prisms and we are asked to find the volume of them. So the first example here is kind of an L-shaped prism. Okay, we have this L shape which runs from the front of this shape all the way through to the exact same L shape at the back. So when we're using the formula V equals AH, and remember what we said, A is the area of the constant cross-section. In this case, the constant cross-section is this L shape that runs all the way through. So A is 32. Now this question is quite good in the fact that it tells us the area in advance, so we can just write 32 for the area. In other words, we're actually given the area, which is a good thing. Okay. Now H is for height. Again, you might be thinking height would be this length here, but remember we said this can be AL or AH for this formula. We tend to just use one or the other. It doesn't really matter. If you want to use AL for this, that's fine. But the number that goes here is the distance between this L shape at the front and the L shape at the back. In other words, whatever area we use, how far does that travel from front to back? And that's 4 centimetres. So 32 times 4 is 128. Now it's a volume, so for area we use square units, but for volume we are going to need to use cubic units, so cubic centimetres. So a fairly straightforward one there, where you're given the area of the constant cross-section. The next example, part B here, it's the same idea. You're asked to find the volume of the triangular prism. So again, we would set up with our formula. Volume is area of the constant cross-section times height. And again, you might want to write V equals AL if you prefer. But what we've got here is a problem, because when we go to write in the area of the constant cross-section, we realise we need to find the area of the triangle. Now the area of the triangle is not given in the same way that the area of this constant cross-section was given. The area of this is not given. So we need to calculate that. And to do that, we need to know the formula for the area of a triangle. And now you should know this from first and second year. So area equals a half times base times height. Now that's going to be a half times the base of the triangle, which here is 6. So half times 6 times the height of the triangle, which is here as 8. So half times 6 times 8. Now half times 6 is just half of 6, so that's 3. And 3 times 8 is 24. So it's 24. Now this is an area, so that is square units. What I've then got is I now know the area of that cross-section. That 24 is the area of this shape here, which means if I'm looking to find the volume, it's equal to the area of the constant cross-section, which is 24, times h, which would be the height of the shape. But in this case, we think about the height as being this length here, the distance between the triangle at the front and the triangle at the back, remember. Okay, so that is 10, and that's going to give me 240 cubic centimetres. Now, as before, we don't want people to get hung up on this h or l part here. So if you prefer, if you want to think about the h being the height being 10 here, imagine just tipping that triangular prism up so that the triangle is sitting on the floor. And then this would be the height. It just depends on which way you're looking at the shape. In this question here, we have another prism. Okay, the garden shed, it's in the shape of a prism. You've got a constant cross section that runs all the way through. So this shape here on this side is running all the way through to the back of the shed where you've got the same shape. So if we want to use our formula, V equals area times height. And again, height in this case, it's the distance between this shape at the front and this shape at the back here at the other side. So that's going to be the h for this space here. So I can put in times 2.8. But the area part here I need to find. So I need to know what the area of this shape that is constant throughout actually is. Now I'm going to have to do that in parts. So what I'm going to do is I'm going to just very quickly sketch out that shape over here because it's a bit more complicated than just a plain triangle like on the last page, and I'm going to split it into shapes that I know, which is a triangle and a rectangle. Now if you know the formula for the volume of a trapezium, you could use that here, but I think in this case we'll probably just use the rectangle and triangle for this. So a couple of lengths on there. We've got 1.6 from there to there, so here to here. The height of the rectangular part, which is this line here, is 1.5, so 1.5 there. And I need to know the height of the triangle. So far I have the base of the triangle, that's going to be 1.6 from there to there, because it's the same as that. The height of the whole shed is 2.2, and we know it's 1.5 to here. So the difference between this height and this height here is an extra 0.7, so I'm going to put 0.7 up there. So that makes sense as 1.5 to be level with this part, plus another 0.7 to get to the top. So we're going to then label them, area 1 and area 2, and I'm going to calculate each of those in turn. So let's start with area 1, which is a triangle. Formula for the area of a triangle, again we should know, a half times base times height, which is a half times 1.6 times 0.7. Okay, now that's equal to, we can use our calculator for this one. It's going to end up being 0.8 times 0.7, so 0.56. And then we've got area 2 is a rectangle up here, so down 1.6 by 1.5. So length times breadth for a rectangle, 1.6 times 1.5, which is equal to, which is 2.4. Now that means the total area of this cross section, this constant cross section, is this plus this. So the total area is equal to 0.56 plus 2.4, which is 2.96. From there, we now know the volume, we now know the area of this constant cross section is 2.96, so that can go into this space here for the area of the constant cross section, so that goes 2.96 in there. And then all we've got to do is do this final calculation here on our calculator. So 2.96 times 2.8 gives us 8.29, oh, hang on, 8.29, and that is cubic meters. And that's just 2 decimal places there.